Hello everyone, welcome to AI Anytime channel. In this video, we are going to build a RAG interface using all open source stack that we can leverage starting with Llama 3.2 model. It's a new multimodal model by Meta AI. So we're going to use Llama 3.2, which is going to act as a bedrock, for this entire RAG pipeline. Then we're going to use Qdrant, that we will run within a Docker container locally. We're not going to use any API, no cloud, nothing. Okay, completely in my system, in a laptop that I have 16 GB where I'm recording this video. We're going to use LangChain as an orchestration framework. And for creating the vectors, we're going to use BGE embeddings by Beijing AI Academy, one of my favorite embeddings model right there. And one of my favorite model that helps me with feature extraction. You can use Nomic, you can use sentence transformer, mini LML6, B2, MPNet, base, whatever. You can use different embeddings model from Hugging Face. I'm going to use unstructured PDF to basically pre-process the PDF, like splitting and so on and so forth. So end-to-end, entirely, open source, running locally on a very compute limited device like 16 GB. You will be able to run this on 8 GB as well. I'm pretty sure about it because the model size is 2 GB. Because I'm using the I'm using the 3B model, which has 2 billion size params when it comes to quantization. Because we are using Llama. Llama is a framework that helps you inference large language models on a compute limited devices on CPU and etc. If you look at here on my screen, that we call it document buddy app. This is a great project if you are, if you want to add a project in your resume or a CV. You are a beginner. Also, if you are like working in AI itself, you can use this project completely open source. I have already created the entire GitHub repository. You can just go and reproduce it. You can just use the steps to basically use it wherever you want to use it. Make money out of it. I'm completely fine with it, right? So now we call it document buddy app. Here you have something called chatbot. Now if you look at the chatbot thingy, it has three different columns. By the way, we are using Streamlit, to build this application. Okay, we have three sections in this: column one, column two, column three. We are using Streamlit.columns. You know, it says upload document, embeddings, and chat with document. Now in upload document, the idea is you upload a file. I want to build it real time. You can do offline indexing and vector database creations, up to you. I have 45 plus RAG videos on RAG playlist. If you watch it, you'll become a RAG expert. I can vouch for that. But here the idea is how you can upload, because the idea is to build a modular app. You take it, deploy it, put a payment gateway here, scale a bit, connect some databases, so on and so forth, and make it a fully functional app and make money out of it, right? That's how you can do it. It's not rocket science, guys, by the way. Now, if you look at here on upload document, I can upload a document over here. So I'm uploading this gastro document. There's a case study that we have, and we have a document preview. It automatically previews your document, so you can basically have a look at the document that you are uploading here. It says gastroesophageal surgery case. It's a case study of stomach, somebody who is suffering through a stomach cancer, or who has suffered through a stomach cancer rather. It's a case study given by Massachusetts General Hospital. So thank you so much for them. It's a public document. I downloaded it from open internet. It's pretty good when it comes to case study. You can have these kind of use cases. You are working as, as an intern, or you are working in an enterprise and a startup. Your leaders will come and say, your managers will come and say, let's build a chatbot, let's build a RAG, let's build an AI agent. We have to retrieve information from documents, policy document, this document, that document. So you can use this kind of pipeline, by the way. Now we are good with column one. Now the column two is creating embeddings. What do you mean by embeddings? This is a document, guys. As a human, we can interpret this document. Machine can't. So if a machine can't, you have to create a numerical representation so the machine can understand these documents. So embeddings is something where we create a numerical representation of our data. That can be different types of data. It can be text, it can be images, so on and so forth. Now, to create the vectors, we're going to use a model, and we are using, and I'm going to show all the code and everything in a bit. Let's first go to the demo. Now, it will first use an open source model called BGE embedding model by Beijing AI Academy, BAAI. from Hugging Face, and we have some pre-processing steps that it goes through and then create vectors. And then there's once you create these numerical representation, you have to store it. Now there are two ways you can store it. But rather I'll say three ways. You can store in a list, Python list also. But imagine if it's the document are too big, storing in Python list is not scalable. You can't scale that, right? You will start getting memory index out of it and so on and so forth. The other way is to store in a database store, okay, a locally persistent or a cloud driven store which has limited features and functionalities, like okay, you can serialize your data, you can index your data, and then you can deserialize when you are asking some question. That's basically a store like fires and chroma and so on and so forth. But that also not scalable. You can't scale it if you have huge data sets, and if you want to do a very latent free where latency is not a problem, then you need something which is more scalable, right? Vector databases. That's the third thing. You can use Qdrant, Waviate, Milvus, so on and so forth when it comes to open source. Pinecone, Vertex AI, Matching Engine, AWS Open Search Service, MongoDB, etc. when it comes to closed source vector databases. Now here we are using something called Qdrant. They just did their series, if I'm not wrong, series A or something. They raised a lot of funds, by the way. They're doing really good. Now, when I click on this, it will create the vectors and store that in Qdrant. Now, what is Qdrant that I'm talking about? So let me show you here. So for Qdrant, there are two ways you can do it. So first, let me show you. I'm running it through Docker. Now, if you want to understand what Qdrant is, just go on Qdrant and it will take you to Qdrant website. Open source vector database, high performance vector search at scale. Of course they are, by the way. Now, if I come back here, and you can use Qdrant through two ways. One is self-hosted, the other is through cloud. So if you are not somebody who is really technical or don't have technical expertise but have an idea to build a chatbot, then you can use Qdrant cloud. So you can go on Qdrant Cloud, take an API key from there and start using it. But I want to keep self-hosted. So all the vectors that I have remains within my own infrastructure, within my own network. It doesn't leave my own infra. So I will keep all of my data completely private. So if when you are someone who is really focused on privacy, if you're working in some regulated industries, then you have to self-host it. Don't use Pinecone, okay? Because then you will be in trouble, guys. Now, locally you can do it in two different ways. One is through Docker, the other is on disk, like and that's not scalable. So you're gonna use Docker. So Docker is a container technology. Now, how you can use Docker to get Qdrant? You have to do Docker pull, and you can see it's suggesting me here, and then just do Qdrant/Qdrant. I have a couple of videos on Qdrant for beginners. I'll give the link in description. Have a look before this video if you are not familiar with Qdrant. Now, once you do Docker pull Qdrant/Qdrant, it will pull the images. So if I show you Docker images, all the images that I have will be here, available. You can see when I do Docker images, the first one is Qdrant/Qdrant. Now when I do, let me just first clean this. When I'm going to do Docker PS, it will show me all the containers that's running right now, leveraging all the images that we have. Now you can see I have a bunch of containers that's running, by the way. Now I'm already running Qdrant. Okay, so if you look at here, what I'm doing Docker run -p. So run command means that it's going to run an image within a container. So here we have Docker run -p. P means which port. So Qdrant by default is looks for 6333 port. So you can see 6333, and then I'm passing one more input param called -v, which is an argument args over here, and I'm saying dot. What does dot means? Dot means that I want to I want to mount the volume where I'm going to keep all my vectors for a given document, and that's the directory. So dot means that current directory where I'm running this code should be used to mount the volume. So all my vectors stored in that particular directory, the current directory dot. If you don't want to use dot, then give the path of wherever you want to store it. And then I'm just giving Qdrant blah blah blah. And you can see it says running right now here. Let me open it, guys. Now if you opened it, you can see it's running locally called localhost colon 6333/dashboard. Qdrant gives a very intuitive dashboard. That's why I really like it. So you can see we have a collection called vector DB. And once you make any new document, it basically updates it. So we have vector DB collection. If you click on that, you can find out all the documents, so on and so forth, right? So far what we have covered the first part where we have upload document and your document is visible. Then we are right now in the embeddings part. So when you click on the checkbox, it creates in real time, guys. It will create the embeddings in real time for this given document and store it over here, in this localhost 6333 Qdrant vector database that we are running. So if you click on create embeddings, you can see it says running. And once you do that, it will show you here a status message that your embeddings are created, updated, stored, blah, 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 whatever. So that's what the embeddings thing here is. Okay, so let's wait for it and create embeddings. Now the idea is to use Llama 3.2 to build RAG chatbots, not only inferencing it, because inferencing video I don't want to create for this model because that code is already available on their Hugging Face repository. So I don't want to cover the news only here that Meta has released Llama 3.2. I don't think that there's a video which is required to cover a news in AI. My focus is to build AI projects so you guys can leverage it. Right now you can see here it says vector DB is successfully created and stored in Qdrant. So we have covered two parts: upload document, pre-processed document, creating vectors, and vectors are stored. Now the third thing is chat with document. So for chat with document, for the chat with document, what you have to do, you have to first uncheck this. And now, as you know that vectors are created, you can ask your question. So if you look at my GitHub repository also, I have given this this repository, which is private right now. I'll make it public once I post the video. You can find out the entire repo over here, completely detailed with a README. So you can just go and, replicate. So if you click on this image, okay, it shows the same screenshot. Okay, so I'm just going to ask a question here, like, uh, list down all the past medical history which are available or something. And what I'm expecting, it says responding. Okay, so how is responding is not a question now. That's so model here, the LLM. That's what you should know. Okay, so let me show you how I'm doing it. I'm using, you can see the answer. Let me first show the answer. It says the patient's past medical history is as follows: type 2 diabetes mellitus, hypertension, elevated lipids, gastroesophageal reflux disease, diverticulosis, endometriosis, kidney stones, anxiety, osteopenia. Note that there is no history of stomach cancer, but her brother had colon cancer that metastatized to the liver and lung. Now you're getting such a beautiful answer, guys. And we did everything in real time. Okay, nothing is happening offline. But I recommend that you can scale this up to accept more document, of course, and connect with a database like Azure Blob Storage or S3 Bucket or whatever, and then you create the embeddings and then have a chatbot. That's up to you. Now, how have this answer generated? Now, this answer have been generated using an LLM called Llama 3.2 3B Instruct. This is a model. Again, every week we are getting a new model, so very difficult to like try these models, but they have done good. On the leaderboard, Meta AI has released that. You can see Meta Llama and Llama 3.2. Now, we cannot directly use this model in a compute limited device because it will be pretty slow. If you want it fast, you can see how fast it was, right? I just asked a question, within 4 or 5 seconds I got an answer, and I'm running on a 16 GB CPU. There is no GPU, right? Now I'm using something called Llama. So Llama is a very innovative inference framework where you can use these LLMs through some kind of decoding technology, compression technology, where we use quantized models, and Llama provides that. But don't forget Llama CPP. All these things that you use, Llama, Cobalt AI, H2O AI, LM Studio, C transformers, and blah blah blah, all were inspired by Llama CPP. But to use Llama, you can install it. Let me first show it. You can download on Windows machine, Mac OS, and Linux. Pretty easy. So click on download. When you click on download, it shows here that how you can install it if you haven't installed yet. Right now, I already have installed it, and this is how I'm running it. So when you install it, you have to do two things. If you have installed for the first time, you have to first pull the model before running it, because the model will not be available in your machine. So you have to do same very simple thing. Right now I'm writing run here, right? What you have to do, you have to write o llama pull. Use the word pull. It's a very famous word in computer science, guys. If you are using Docker, you have to use Docker pull, Qdrant slash Qdrant, Waviate slash Waviate, Ubuntu slash Ubuntu, Fast API, whatever. So whatever official repository they have pushed it on Docker Hub or anywhere else, you have to pull it like that. And the same goes with Llama, because all of these, trust me, are saved somewhere in a repository that are again managed by a Git version control. So you have to just do o llama pull llama 3.2 3b, and once I have pulled it, I'm just doing o llama run llama 3.2 3b. Now once you do that, I want to show something to you. O llama runs on port 11434, so you can see it says o llama is running. What does it mean? That the model is running, listening at this port called 11434, and we can use this in external program. Okay, any program that you are writing outside this current program that we have for Llama. So for example, if you look at here, I have my own program and I'm going to explain that to you. First, I wanted to show you the demo, and this is how the answer has been generated. But how answer has been generated is the question now. So let me just go back, and show you something. Okay, so what I want to show is, I want to draw something, guys. Okay, here on my tab. If you are someone who are already an expert, guys, I understand few of you comment that I'm explaining this in very detail. See, not everybody is an expert like you. Okay, there are few people who might not know this knowledge, and my channel, I create videos for people who have no knowledge. I want to explain everything. So if you are someone who doesn't want to watch this segment, feel free to skip it to the program or whatever you want to see here. The reason that you are on my channel. So if you don't like anything, it's your perspective. You are only thinking from your perspective, right? I have to think from everyone's perspective. So please respect that. Okay. Now here what I'm gonna do, I'm gonna write here the workflow. So let me explain the workflow to you. So you have document. Now you have the document. So the first thing that we do when we have a document, we used some kind of loader, and that's where we are using unstructured library. Unstructured uses PyTesseract, popular utils, Ghost script, so on and so forth as backend engine, depending on what file formats you are dealing with. So for CSV, it will be different. For PDF, it will be different. For docx, it will be different. Open source, that's why I'm using it. They also provide it through cloud. So if you want to use API, you can also use API for unstructured. But if you are going for unstructured API, I will recommend you go for Llama parse. Don't use unstructured if you want to pay money. If you want to do open source, then unstructured library is good to work with. Now, unstructured library, I'm using PDF loader within unstructured class loader, and then you use some kind of chunking. So I'm using a pretty simple chunking. I'm using recursive uh, C text splitter. So I'm just writing recursive text splitter. But depending on the complexity of your PDF, now if your PDF has a lot of tables, if your PDF has context on each page, so each page there is a heading and there is paragraph, then you do page split. So depending on that, and you can also use advanced chunking methodologies like semantic chunking. There are different types of chunkings that you can use, and you can basically follow on these documentation. So it's up to you, but don't unnecessarily go into complex things if your data looks very simple. Okay, now recursive CTS, when that is done, recursive is done, then we're going to use an embedding model, and in the embedding model we create basically some embeddings, okay, some in lower dimensional spaces, some vectors that get basically stored. And for this, if you see what we are doing, we are using Qdrant here, which is running locally. So Qdrant has been running locally. I'm first creating the flow. Now this basically has stored our vectors. Now we are good so far. Now if we talk about the retrieval, when an augmented retrieval, now talk about the RAG inference now. So in the RAG inference, a user comes in, user asks a query. The first query again use the same, embedding model over here, that the embedding model you have, the same embedding model. And again, it also creates a numerical representation. Now for this numerical representation here that you see, here it finds out a different searching algorithm. So for example, if you are doing semantic search, a pretty much distance based algorithm, okay, like cosine similarity, or any approximate nearest neighbor, the ANN algorithm. So I'm going to say distance or ANN algorithms that you're going to use, and that basically what it does then, when this step is done, it basically gives you, there is a param called top k, like how many document you want to retrieve. So for example, documents are nothing but the context, the paragraphs. Now if I say 3, it basically gives me, okay, I will write text here. Okay, so I'm gonna write text 1, text 2, and text 3. Now these text basically goes through an LLM that has augmentation through your prompt plus chaining. So basically you have a prompt template where you define some instructions and examples and so on and so forth, right? And then LLM. Now these LLMs are used by Llama. You can see it over here. So we have Llama over here. We have Qdrant. So these are the major things that we have. And for LLM, we are using, what LLM we are using, guys? We are using Meta Llama 3.2b. Sorry, excuse me, not 3.2b. Llama Meta 3.2. And then it does an augment, and you get a response. That's what the flow is. That's the workflow, guys. So you started through a document, you have some pre-processing steps over here, then you created a chunking, and then you used an embedding model. Here we used BGE, and then BGE we used embedding model, and then you created and stored in Qdrant, and then user asked the question. It basically, you just ask a question, then it has the same query. It uses the same embedding model over here, get the same numerical representation, and finds out the semantic search. And on semantic search, then it does your retrieve top 3 documents, and after the retrieval we pass it to an LLM, because retrievers might be half baked product. It's like broken words and keywords. LLM has to augment and synthesize the response, and then why it's called RAG, Retrieval Augmented Generation. So enough of flow and demo. Now let me show you the code. So I'm going to go in code. By the way, this is already available for you, Document Buddy app. Go and clone in. Please don't forget to start the repo. You should start the repo. That will help me to create more open source projects. Now I'll give you a walkthrough. Okay, so I have built this. I've done a lot of coding here, by the way, but if you look at the vectors.py, that's the first file you should look at it. Okay, here, so I have vectors.py. I'm using LangChain. So we are using unstructured PDF loader. We are using recursive character text splitter, Hugging Face, BGE embeddings, and Qdrant. I have a class called embedding manager. In this class, I'm defining everything that I have to define over here. You can see model name, device, encode. There's some normalizations, Qdrant URL. This is where the Qdrant is running. Collection name. What should be the name of the collection? So it should be vector DB. And then I'm just pretty much modular codes that we have over here that you can see, creating the embeddings. Pretty much I have documented it quite well, so you'll find it very easier to work. And you're creating the embedding. You can see this is how you load it. Loaders, docs, load, then creating the text splitter. Pretty much good error handling as well at every step. Chunk size 1000 and chunk overlap 250. Always keep 25% overlap for your chunking size. So if you have 1000, it should be 250. Okay, that's the industry recommendations, by the way. Now I have created the vector database here. It says failed to connect, or vector database successfully created and stored in Qdrant. Now this is the vectors thing. Now once you have the vectors, you have to create one more file that I've created called chatbot.py. Now in the chatbot also, same model that we have to use. Qdrant with required. I'm using chat Llama from LangChain Llama, prompt template, and retrieval QA chain. That's what I'm using. You can also use LangChain expression language, LCEL, a new way of defining LangChain chains. You can also use that. Now here I have a chatbot manager, a class, again defining the same params. Here I'm just using LLM model and LLM temperature. You can easily change any other model, guys. It's up to you. You can give options on the Streamlit tab, and that's where I'll come to you how you can do a pull request and keep working on the app, and I will feature you, on our Discord community and WhatsApp community and YouTube as well. Now here we have again the self very pretty much modular coding that we have. Self LLM here we are defining the chat, Llama and everything going. The prompt template, pretty simple prompt template. You can make it a bit more comprehensive. And here we have our Qdrant client, database retrievals, prompts, passing the input variables, self retriever. I'm only doing k equal to 1, but you can increase it. You can use read anchor if there's a very complex document. And then we have chain type, some initializations, blah, blah, blah. And basically it works. Now let me show you the main thing, new.py. Using both the classes and Streamlit and session state. First, I'm writing a function that will be used to display PDFs over here. And then I'm initializing some session state variables, for all the things, PDF, chatbot, and messages. Pretty much Streamlit thing, the layout, wide, and the favicon, so on and so forth. Sidebar, putting up a logo, personal document assistant, a menu, and now we're gonna have use all these menus. So first is home, have some, markdown, some kind of descriptions. First one is the chatbot. In the chatbot, I have a title, defining 3 different columns. In the first column, have the upload document, file uploaders, checking if the file is not none. There should be file before we process it. Finding out some basic info like the file name, the size, and previewing the file using the display PDF and saving it as a temp.pdf file and using the same temp.pdf to create the vectors. But if you want to scale this, you have to save this temp.pdf in a database. Okay, wherever on cloud or locally, if you have some self-hosted SQL database or MongoDB self-hosted, whatever. Now here I am create embeddings, column 2. I'm using the class, pretty much self thing, just trying out in sliding the embedding manager. You can again change it here, quite modular that we have created. Creates, it says that embeddings are in process, creates the embeddings, blah, blah, blah. And then initialize the chatbot manager only after embeddings are created. Then only it will be enabled. In the column 3, I have chat with data, initializing the session state, displaying existing messages, like whatever text that you want to give, and using user input, displaying the user message through the chatbot.py file that we have, and then just contact us. That's what it does, guys. Okay, and that's how we build this beautiful application. Not writing the code because these are very duplicated code, guys. If anyone is saying that I'm building RAG from scratch, it's like, that's crazy then, by the way. Okay, now this app, go ahead, try it out. Let me know if you have any questions. My idea was to create a RAG chatbot on Llama 3.2. I don't want to create an inference video or covering the news, as I said. Completely open source. I love open source. I've been creating a lot of open source video. I think one of the first YouTubers who created an end-to-end RAG like a year, more than a year ago when first Llama was, in the news. Okay, so use this. Let me know if you have any question, thoughts, or feedbacks. You can comment it down. You can also reach out to me through my social media channels. Find those information on channel banner and channel about us. Join our Discord community, guys. Very helpful for you if you want to learn Gen AI faster. We help each other. I'll give the link in description. This complete code is available on my GitHub repository. I have put a lot of effort on this. Go ahead, do a pull request if you want to contribute to this. You can make it a lot of things. Summarization chain you can bring up here. You can give model selection options and so on and so forth. Now, if you like the content, please hit the like icon. If you haven't subscribed yet, please do subscribe the channel, guys. That motivates me to create more such videos. Watch my RAG playlist if you want to master RAG. Watch my fine-tuning playlist if you want to master fine-tuning. Watch my evals playlist if you want to master evaluations, monitoring, so on and so forth. All are the playlists that you can see. That's all for this video, guys. Thank you so much for watching. See you in the next one.